All right, lesson 4, comparing methods, our last day on long division. So we talked about long division using the reverse tabular method. Now we're talking about long division just a different way. This is actually how I prefer to divide polynomials, but you may use whatever method works best for you. First of all, let's do a little review. Use the reverse tabular method to determine the quotient. Okay, I'm going to push pause because remember this is sort of like your warm-up. And there we have our quotient. Okay, push pause, check it out, and write down any questions you might have. So, use your work from exercise 1 to write the polynomial 2x cubed plus 11x squared plus 7x plus 10 in factored form, and then multiply the factors to check your work above. Okay, that just means we're doing the backwards thing again. Factored form is just 2x squared plus x plus 2 times x plus 5. So that's factored form, so we're really just doing the reverse of what we just completed. Okay, doing some multiplication. That's a bad x. So if you remember, we multiply columns and rows, columns and rows. So 2x squared times x, 2x cubed, x times x, 2 times x. 2x squared times 5, x times 5, 2 times 5. And then we add diagonally. I have 2x squared plus 2x cubed, 11x squared plus 7x plus 10. Okay, just making sure that every piece of, we have our factors, we have our quotient, we have our product, everything. Sorry about that. There's a weather radio in here that I can't turn off. All right, now let's look at example 1. If x equals 10, then the division of 1,573 over 13 can be represented using polynomial division. That just means that x cubed plus 5x squared, 7x 3 over x plus 3. Okay, it can be represented with a polynomial. Okay. Okay, this just means, if you look at the factors here, each place value in a number such as 1,573 just represents place value. So our place is really if x equals 10, x cubed, because x cubed is 1,000 with 3 zeros. 5x squared represents 500. 7x represents 70. And 3. Divide by 13, so 13, the first term is really x in the second term. So the division of this number can be represented pretty quickly if we assume that x equals 10 by polynomial division. I'm going to go ahead and erase that so we can work through our problem though. I'll push pause. First, let's do the math. 1,573 divided by 13, and see if we can make some parallels here. Because if you remember, this is representing 13, and this is representing 1,573. So 13 goes into 15 one time, subtract, carry down a 7. 13 goes into 27 twice. 2 times 13 is 26. 13 goes into 13 one time. 1 times 13 is 13. Remainder 0. So the number 121, what would it represent in polynomial if we assumed x is equal to 10? We've got x squared plus 2x plus 1. So that should be our answer. Let's see if we can get that dividing the polynomials. So first of all, what expression multiplied by x will result in x cubed? We're wondering how many times x is going to go into x cubed. I would say x squared. So we are going to put x squared right there. And then multiply through. Okay, x squared times 3 and x squared times x. X squared times 3, x squared times x. And then subtract. We're left with 2x squared. Carry down. X goes into 2x squared how many times? I would say 2x, and then multiply or distribute through. 2x times 3, 6x, 2x times x, 2x squared. Subtract. We can see that this last one is just times 1 because we're going to have a remainder of 0. So here we have our answer. Pretty cool. And amazingly enough, it matches what we thought it would, which is very fun. Cool. All right, example 2. Using the long division algorithm for polynomials, we want to evaluate what's given. So let me write it out. 2x cubed minus 4x squared plus 2 divided by 2x minus 2. Okay, so again, we want to ask the question, what times 2x equals 2x cubed? Or I always just thought 2x goes into 2x cubed how many times? We're going to do x, oh, and I put that in the wrong spot. If we have two terms here, we need to make sure we have two terms here. So we're going to write our answer above the second term. So we need x squared. Distribute through x squared times 2x, x squared times negative 2. We have 2x cubed minus 2x squared. Okay, subtract, which when you have a negative can be a little bit tricky in your mind. I have a negative 4x squared, minus a negative 2x squared. So, in essence, negative 4x squared minus a negative 2, which would do that. So I'm left with negative 2x squared. Okay, how many times does 2x go into negative 2x squared? I'm going to say it's minus x. Multiply through. Negative 2x squared. So negative x times 2x is negative 2x squared. Negative x times negative 2 is positive 2. Oh, I forgot to carry down. So sorry. I'm sure you guys caught it. I have a remainder of 0. Okay, I have discovered my mistake. Did you guys catch my mistake? It's right around here. So I'm actually going to help you learn from that mistake and start over. I need to account for 0x plus 2. I need all of my terms. Cubed, squared, first power, constant. So I'm going to push pause and erase this and start over. So you can just cross out your classwork and start over. Hold on a sec. Let's try this again. Okay, so we started this out correctly. I'm going to write 2x, sorry about that, 2x squared up here, and then multiply through. Nope, just x squared. X squared times 2x is 2x cubed minus 2x squared. And this is where I need to make sure I'm subtracting. So try not to mess that. 4x squared, negative 4x squared minus negative 2x squared is negative 2x squared plus 0x. This is going to be just minus x. Negative x times 2x is negative 2x squared. Negative x times negative 2 is positive 2x. And that leaves me 0 minus 2 is negative 2. And our last term, negative 1. Negative 1 times 2x. Negative 1 times negative 2. Remainder 0. So we have our answer. Good job. All right, exercises 1 through 8. Use the long division algorithm to determine the quotient. For each problem, check your work by using the reverse tabular method. Okay, for these, it's 8 problems. I would go through a few of them. I'm not going to make you do all of them if you understand what's going on. And then you can go ahead and start your problem set. Because if you do these 8 problems plus your problem set, that's a lot of division. So I'm going to work through each one of them, pushing pause. You can work through them until you get comfortable, and then move on to your problem set. If you have any questions, please ask. And you're always welcome to email me. I'll do my best to email back. So I'm going to push pause and work through this problem. There you go. Check it out and move on to the next one. I'm pushing pause again. Okay. Here you go. Notice it did tell you in the instructions to check your work using the reverse tabular method. You can go ahead and do that, or you can just distribute and multiply if you'd like to check your work. It's a good practice to get into. Okay, I'm going to push pause. There you go. Just want to point out that minus and negative may throw you off. So if you're making mistakes, double check those. We were missing 2 terms in the middle of the top. So we have to put those in there, or the math just doesn't work out as well. Okay, we're on number 4. I'm going to push pause. What I'd like to point out here is our dividend, it was missing a term. So it's really important to put that in there. And I'm actually going to page back to the previous slide. Okay, number 5, push and pause. Did this one throw anyone else for a loop? It got me. So our final answer is just that. Make sure you put your placeholders in before you start your math. Okay, next one, push and pause. There you go, number 6. Okay, number 7, we're at x to the 5th minus 2x plus 7. And number 8, x to the 5th minus 2x to the 4th plus 4x cubed minus 8x squared plus 16x minus 32. Okay? All right, in closing, which method do you prefer, long division or reverse tabular method? Is one method easier than another? This is totally your preference. I like long division. This is very organized and I like it, but setting up the tables takes up a lot of space. What advice would you give a friend that is just learning how to do these problems quickly and accurately? It really depends, but I would say be careful. Put in zeros. And subtract carefully. Okay, we might do an entry ticket tomorrow. Just always be prepared. Nice work today.